Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through the derivative of sine. We're going to differentiate y equals sine x. To do that, we need to use first principles. And it turns out to use first principles, we'll need to use expressions like this. So I've just drawn up a table, so I've picked different values of h. You can see the h values are getting closer and closer to 0. They're decreasing. And then I've taken each value of h and substituted into this expression and also to this expression. So as h is getting closer and closer to 0, you can see that sine h over h is getting closer and closer to 1. In fact, down here, it's like so close to 1, basically is 1. So the way we write that mathematically, we've discovered that the limit as h approaches 0 of sine h over h is equal to 1. Now I need to make sure that you understand that this only works. This is true when h is in radians, when we're in radians. That's what the little c there means. Okay, same sort of idea. H is getting smaller and smaller each time. So what happens to this expression here? Well, it starts off very close to 0, then it gets a little more negative, and then you can see it gets closer and closer to 0. So as h is getting closer and closer to 0, this expression cos h minus 1 over h, it does some weird things. It goes like up and down, but eventually it settles down and gets closer and closer to 0. And we write this mathematically like this. So it turns out we'll need both of these when we try to differentiate y equals sine x. So let's go and do that now. So this is just the first principle formula, and we will use these two things that we figured out on the previous slide in this formula to differentiate the function fx equals sine x. So if fx equals sine x, f of x plus h, all I do is take my function and replace all the x's with x plus h. So I'll just put in brackets this time, equals sine of x plus h. Now when we did trigonometry last year, we used what was called the double angle formula. There's a way to expand this. It turns out that this is the same as sine of the first, cos of the second, plus cos of the first, sine of the second. So we need that trick. I'm going to substitute this and this into this formula up here. So using the first principles formula, we have the limit as h approaches 0 of f of x plus h, this thing here, minus f of x over h. So what we're going to do, because this first term and this third and last term here both have a sine x, we're going to factorize. So what I did was just took this term, and put it like this. If you expand this, you get sine x cos h minus sine x, and then this middle term here, the second term, I just left over here. So what we can do is we can split up this fraction. This over h plus this over h. So now to take the limit of this whole thing here, I can just take the limit of this fraction, the limit of this fraction, and add them together. So let's start with this first fraction here. But we actually figured out in the previous slide that the limit as h approaches 0 of this thing here is just 0. So this is just going to equal the first part, sine x, because that doesn't depend on h, sine x times the thing in blue is 0. And when we take the limit as h approaches 0 of this fraction, well, we figured out that the limit as h approaches 0 of this part is 1. So we're going to be left with cos of x times 1. Now, of course, anything times 0 is 0, so this is just 0, and this is just cos x. So we've actually figured out that the derivative of sine x is actually cos x. So that means if you want to find the gradient at any point along the curve y equals sine x, its gradient is just whatever cos is at that particular point. So the derivative of sine x is equal to cos x. Now we'd follow a very similar process if we wanted to differentiate y equals cos x. We'd still use these two facts. We'd still use this formula. It just turns out that the derivative of cos x is equal to minus sine x. But I'll leave the proof to you as an exercise. So what we've learned here, the derivative of y equals sine x is equal to cos x. The reason is first principles and a couple of these limits here. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.